All right, welcome everyone to 8.3b. This is the last one was very theory focused. This one is going to be heavily focused on examples. We just got loads of examples ready for you guys. And it should be a pretty nice day. Because again, your calculator can help you through almost all of this section. But the reason why it's important to do it by hand is when we go into the future section and go into things that your calculator will not be able to help you with. Being able to apply these concepts is going to help you greatly. So we're going to essentially be doing all of this by hand, but on quizzes and exams, don't worry, you can still use your calculator. So here we go. This is the last section before we move on to chapter 9, which is my favorite chapter of the whole class, and it should be a good time. We'll be starting that up next week. Anyway, here we go. We're on example 2, I think. Evaluate. So part A. I gave you, hold on, part A is going to be the inverse sine of 1/2. All right, and for these questions, like for most of the stuff, I will be giving you these special triangles because these are very useful. All right, so there's kind of a colloquial way of thinking about this part A, something like this. And this is not exact. This is not exact mathematical stuff, what I'm going to write down, but it's a good way to think about it. Essentially, the way to solve this problem is sine of what, unknown, right? Sine of what equals 1/2. All right, and this is not exact, and we'll talk about why it's not exact later, but this is the general idea for how to evaluate the inverse sine of 1/2. Because there's the whole idea of inverse sines is they undo sine. Okay, so sine takes in an angle and gives out a ratio. Inverse sine takes in a ratio and gets out an angle. All right, I got this from Indian Casino Convention or something, indiangaming.org. We got product placement in this trigonometry lecture. All right, so this is roughly the question you want to ask yourself with some caveats. And the caveats is we are going to have to go back to this table that in my skeleton notes is not filled out, but you have it. You have that table. All right. So anyway, here we go. And we say, okay, the sine of what angle equals 1/2? And it's going to be this angle, which should have been given to you, by the way. The sine of pi over 6 is 1 divided by 2. Okay. So our answer is just pi over 6. Because the sine of pi over 6 is 1 over 2 is the idea. And the important thing is that pi over 6 is in the range of inverse sine. This is as good a spot as any to recall it. Remember that we made a little function or a little table of various inverse functions and their range. All right, we said the range of sine, inverse sine, was negative pi over 2 to positive pi over 2. Or you can think about this, if you want to add an extra table, you can think about this as quadrants. What quadrants are inverse sine going to lie in? And the answer is going to be quadrants 1 and 4. Positive angles and negative angles. Inverse cosine, on the other hand, was 0 to pi. So you can think about that as quadrants 1 and 2. And inverse tangent was very similar to inverse sine, but it's not defined at pi over 2, so that's going to be exclusive. Or again, you can think about this as quadrants 1 and 4. All right, so we're going to be using this a little bit. So since pi over 6 is in that range, that's how we know it is the answer. Because remember, right, and why this is in quotation marks, it's not the exact thing. Remember that there are infinitely many angles that have the sine of that angle being 1/2. I got a cat climbing to get out of my room. Remember coterminal angles, for example. If we added 2 pi to this angle, that would also have a sine of 1/2. If we added 4 pi, it'd also be a sine of 1/2. We could add any multiple of 360 degrees or 2 pi radians and get another answer to this question. But here, there's only one answer because we have to find the thing that's in the range. Okay, so part B is over here. That's going to be, what is the inverse sine of negative root 2 over 2? So think about this, and think about the reference angle, as well as what quadrant it's going to lie in. All right, come on, cat. Come on. Out. All right, now that I gave that totally intentional pause for you to think about what is going on here, we can talk about it together. So first off, we need to identify an angle, a reference angle. And this is what I recommend doing. Leave a little answer for our blank here. Leave a little blank here for our answer over here. And then go off to the side, look at, okay, what reference angle is going to give us root 2 over 2? And what quadrant are we going to need to be in to get that negative? So we go back to our special triangles, and remember that root 2 over 2 is just a rationalized version of 1 divided by root 2. So this pi over 4 angle has a sine of 1 over root 2. So our reference angle here is going to be pi over 4. But pi over 4 is not going to be our answer here, because sine of pi over 4 is positive root 2 over 2. We need a negative. So again, there's a lot of different ones that'll give us a negative, but sine is in quadrants 1 and 4. So we need to be in quadrant 4 here. Specifically, our answer is going to be negative pi over 4. Okay? So again, look at what quadrants all of these have ranges in. Everything is positive in quadrant 1. And then if it's negative, sine will be in quadrant 4, cosine will be in quadrant 2, and tangent will also be in quadrant 4, is the idea for these ones. Okay? So let's move on and just kind of show you where these are all coming from. Inverse cosine of negative root 3 over 2. This is terrible mic placement. I cannot even see what I'm writing because the microphone is right there in my line of sight. So again, we figure out what's our reference angle here. And again, we consult the special triangles, root 3 over 2. And we're looking at cosine. So notice that the cosine of pi over 6 is root 3 over 2. So pi over 6 is going to be our reference angle. And then again, we need to figure out what quadrant we're in. Well, inverse cosine of a positive will be in quadrant 1. Inverse cosine of a negative will be in quadrant 2. So what we need something with a reference angle of pi over 6 in the second quadrant. And if you're getting really good at trig, maybe you can just pump this out right here. But if you have a slow brain like me, draw a picture. Something in the second quadrant with a reference angle of pi over 6. We want to know what is this whole angle right here. So that's going to be pi minus pi over 6. Or you could convert it to degrees if you're more comfortable there. So pi minus pi over 6 will be 5 pi over 6. And again, just to be clear, that's pi minus pi over 6, which is 6 pi over 6 minus 1 pi over 6. 6 minus 1 is 5. All right, this is the weirdest 6 on the denominator ever. That's the idea for these. And again, just to be very clear, these are the only answers. If you type into your calculator cosine inverse of negative root 3 over 2, it should give you this. And if your calculator is set into degrees, it'll give you 150 degrees, which is equivalent and also correct. If your calculator is set to radians, it may give you a decimal, but it'll give you a decimal of 5 pi over 6, which should be about 2 point something. All right. No, that's true. 2 point something. All right. But for all quizzes and exams, I will want exact answers. So you either need to give me an exact answer in degrees or an exact answer in radians, not decimal approximations. Okay. Big warning I forgot to warn my other class about. Also, let me know if there's any questions so far. We're just going to keep going through some examples. Inverse tangent of 1. So again, right, if you think about it, tangent of what is equal to 1? That's what we're thinking about here for inverse functions. All right. Yes, 2 point something is not a real answer for the test. Tangent of what is equal to 1? Remember, tangent is opposite over adjacent. So we go over here to these special triangles. When is the opposite over adjacent equal to 1? Well, that's when the opposite over and the adjacent are the same sides, which is pi over 4 right here. Okay, I have too many pieces of paper here. So the answers, our reference angle is going to be pi over 4, and our quadrant Well, it's positive 1. Anytime you see a positive, we always know we're in quadrant 1. It's only when we have negative angles that we have to worry about what quadrant we're going to be in. Okay, so our answer really is just pi over 4. Like so. All right, we're just going to keep chugging these out. Getting more and more, what letter was that? That was D. Get more and more practice. In some of my other classes, I have so many examples per example that we go through like the whole alphabet. That's not going to happen so much in this class. But example 4 is going to be really close. Okay? So let's go part E. Sine inverse of negative 1. We look at our triangles. When is the opposite over hypotenuse, or again, opposite over hypotenuse, when is that equal to negative 1? Well, it's never going to be for these triangles. So these triangles aren't going to help us. Remember, there were 2 things, though, that could help us. These triangles and the unit circle. Again, remember, right? Recall. Sorry, not recall. Think about this. A sine of what is equal to negative 1? Oh, and recall that sine of an angle is equal to the y-coordinate on the unit circle. So we go over here, draw ourselves a little picture. Well, when is the y-coordinate negative 1 on the unit circle? Well, this is the point 1, 0. Well, that doesn't have a y-coordinate in negative 1. Negative 1 is going to be down here. All right? If you get a unit circle tattoo, you send me a picture, you email that to me. I will share it with all of my students, with your permission, of course. All right, so this is the point. And the question is, what angle is this? And then there's a lot of different ways of thinking about it, but our answer is going to be in here because we're talking about sine. We need to be in the first or fourth quadrant in this range. So it's going to be that negative pi over 2 right here. All right, and that's going to be our answer. So if it's a triangle, if it's a special triangle, find the reference angle and the quadrant. If it's not a special triangle, if it's something on the unit circle, a quadrantal angle, then just the picture will be enough, as long as you know that you're going to be in the right quadrant. Let's look at some more of these. Inverse tangent of negative 1. Very similar to something we did before. Remember, for tangent of positive 1, we said the reference angle was pi over 4. The quadrant was 1. Well, this is going to be very similar. Just like before, our reference angle is still going to be pi over 4. But now to get a negative ratio, we can't be in the first quadrant anymore. That'd be positive. So we're going to go to the fourth quadrant. All right, and get our answer is negative pi over 4. So for sine and tangent, a negative on the inside just means a negative on the outside. But for cosine, it's a little bit more complicated. Anytime you have a cosine situation, you're going to need to graph it to find the actual angle. And let's go back to that comment. If you have sine and tangent, a negative on the inside is the same as a negative on the outside. That is the definition of an odd function. Remember when we talked about functions, right? Sine kind of looked like this. It's an odd function because on the right, it's just a reflection of what's on the left. Tangent, remember, again, repeats infinitely many times with asymptotes. But tangent's also an odd function because what's on the right is just a reflection of what's on the left. Because they're odd functions, negative on the inside means negative on the outside. That's why odd functions are so convenient. And again, when we get into chapter 9, we're going to be talking about a ton of identities, including odd and even functions, but those identities will be given to you for all quizzes and exams. You do not have to memorize those. All right? And this is just one little handy application of that. So let's go on. Inverse cosine of negative 1. The more and more of these you do, the more and more you're going to pick up the pattern. So we first go to our triangles. When is the adjacent over the hypotenuse going to be negative 1? Well, never. The only time we can get a 1 or a negative 1 out of a trig function here, that's not a reciprocal function. No, even with a reciprocal function, is if it's tangent. And then tangent of pi over 4 will give us. But sines and cosines with their inverses of negative 1 will always be quadrantal angles. So again, remember that cosine of an angle is equal to the x coordinate on the unit circle. So we just draw a nice little unit circle over here. When is the x-coordinate -1? And we're right here. So we can think of this angle as pi, or we can think of this angle as -pi. But only one of them is the right answer. The way to know the right answer is remember, okay, cosine is 0 to pi, quadrants 1 and 2. You should be very familiar with these ranges by the time you finish this homework assignment. It shouldn't need a lot of like brute force memorization. As you're doing the homework assignment, try to use this table as little as possible. And after you guess, go back to the table and make sure that you guess correctly. And that'll be a very quick way of just remembering this. But essentially, really, it's only two things you have to remember. And then remember that sine and tangent are essentially the same. So it's going to be this angle right here, which is going to be positive pi. All right, let's do a couple more and then we'll move on to the next example. Inverse cosine of -1/2. So we need to find a reference angle in a quadrant. We go to our triangles. When is the adjacent over the hypotenuse going to be 1/2? So it's going to be this triangle right here. And adjacent being 1 is for this angle. Adjacent over hypotenuse for this angle. What is this angle? It's the complement of pi over 6. It's pi over 3. So our reference angle here is pi over 3. I've never been a big pi person myself, but maybe I just haven't had good pies. And the quadrant, it's not quadrant 1 because it's a negative ratio. Cosine is in quadrants 1 and 2. So again, cosine's really the one we're going to have to draw that picture. A reference angle of pi over 3 in the second quadrant. So this whole angle is going to be, we go pi radians and then go back pi over 3. So pi minus pi over 3, which is just 2 pi over 3. I had my first pecan pie last year, actually. It was decent. It was decent. So that's our answer right here, 2 pi over 3. And again, go ahead and use your calculator to check your answers on these. And so the last one, I'm not going to do very many of these, but I want to do at least one because it's on the homework assignment. Inverse sine of something like this, there's no exact answer for this anymore. This one you have to use a calculator. So all you do on your calculator is just use the inverse sine button, which is usually second, hit the second button, and then sine. Inverse sine is usually right above sine. And you just type that into your calculator and you're going to get something. 0.97 is approximately 1.3252. 4 decimal places is pretty good. But if I ask you, I will tell you how many decimal places I want. And remember, going back all the way to chapter 7, if I write it like this, with no units, that means radians. If your calculator is set to degrees, you need to specify degrees. Okay? No units means radians, degrees means degrees. And that's that. All right, so that's essentially about half of this video. We have a short interlude for something that I think will be very natural for people. And then we'll go on to the end of the section, which gets a little bit more exciting to say. Oh, not part J. Nope. Example 3. Solve for theta. And this is essentially how we can approach the application section of this section. The application section of the section, yes. And if I give you a triangle, it kind of looks like a 45, 45, 90 triangle, but it's not. And I tell you this side's 9 and this side's 12, and this angle is theta. It's not immediately apparent how to solve for theta. But what you're going to do is just relate these two sides and theta. So what trig function relates the adjacent side and the opposite side? And the answer is cosine. So we know that cosine of theta is the adjacent, which is 9, divided by the hypotenuse, which is 12. And again, this could reduce to 3/4, but we don't need to reduce here. You could, though. So what this tells us then is to solve for theta, we use inverse cosine. And that's what we did at the end of yesterday, where we said if cosine of theta equals 9/12, then the inverse cosine of 9/12 equals theta. Essentially, we're taking inverse cosine of both sides and undoing this cosine with its inverse function, because that's the definition of an inverse. And what's the inverse cosine of 9/12? Well, we'll go back to our triangles, and all right, does any of this have a ratio of 9/12 or 3/4? And the answer is no. So this is not one of our special triangles. We will have to approximate right here. Inverse cosine of 9/12, probably use radians. If you do that, you get, oh, not that. If you type that into a calculator, you're going to get 0.7227. All right, so theta is about 0.7227. And if you wanted to use, degrees instead, you get about 41 degrees. So my picture is actually kind of good. 41 degrees is pretty close to how I drew it. But that's just coincidence. I'm terrible at drawing things accurately. All right. Yeah, trig identities are fun. We're going to be starting those next week. Everyone has a lot to look forward to for those. Anyway, let's go on. Let's do a part B. Very similar. We have some kind of triangle like this. Let's say this is theta. This looks like a 30, 60, 90 triangle, but it's not. This is 6. This is 10. So again, to find what theta is, we just need to relate the opposite side with the hypotenuse. So the relationship here is going to be sine. Sine of theta is equal to the opposite over the hypotenuse. And then just turn this into inverse sine. Okay? So sine equals that. So inverse sine of both sides is going to give us theta is the inverse sine of 6/10. And again, you just type this into your calculator. Let's use degrees just for a little bit of a variety. If you use degrees right here, this is going to be about 36.8699 degrees. And again, if you're using radians, the radians is expected. But if you're using degrees, you need to write the degrees right here. Okay. All right, and that's essentially it. Let's do one more just for good measure. Really hammer the concept in. I'm asking you to solve for theta, and let's say this is 2 and this is 3. And this is our angle right here. Well, what trig function can we use to relate this angle with its opposite side and its adjacent side? The answer is tangent. So once you do a couple of these, I think it's going to be very simple for a lot of people. Oops. Because it's really all kind of the same. Once you get one, you can get them all. You just find inverse tangent of 2/3. All right. And you're going to get about 33. This was not on purpose. You can get approximately 33.69 degrees. With 2 zeros, it really is 0.69 right here. All right. So here we go. And that's example 3. Only one more example, and then we're done. There are also N letters. N letters is, I don't know what part of the alphabet, what number that is. But we talked about this earlier, but I'm going to comment it again. Warning, the sine of sine inverse of x, this is actually always equal to x. But sine inverse of sine of x is not always equal to x. It's only equal to x for some x. So you have to be a little careful with simplifying stuff like this. All right. So let's get into it. And I'm going to show you, not the shortcut, I'm going to show you why this is true always and why this is true sometimes. And I honestly truly believe it's better to just do it out than try to figure out when does this shortcut work, when does this shortcut not work. All right. But the short answer is if it's in the first quadrant, it's always going to work. So let's get trucking. Example 4. All right. Evaluate. Part A is going to be the sine inverse of sine of pi over 3. So again, if you can memorize when this equation's true, when this fact is true, I'm not even going to tell you when it's true. You can find that in the book if you want. I really think it's a waste of memorization time to try to do it that way. Let's just approach this the way that we know how. All right. So the sine of an angle is going to give us a ratio, and then we're going to have a ratio in here. The sine inverse of that ratio will give us back an angle. All right. So again, we could go back to our special triangles here. The sine of pi over 3 is right here, is opposite over hypotenuse. So we have root 3 over 2. So notice, since the sine of pi over 3 is root 3 over 2, we just replace it with root 3 over 2. That's what equals means, right? Just like if x is 2, then we could replace all the x's with 2's. Sine of pi over 3 equals root 3 over 2, so we replace the sine of pi over 3 with root 3 over 2. And then again, we go, okay, well, what angle is going to give us the sine of root 3 over 2? And we just go back. But here in this step, this is the step where things can go wrong. And it all goes back to what we were talking about earlier with this range table. So if you have something in the range, then it will always just undo each other. And this is the logic. And I don't think it's really that painful to do this one extra step to avoid having to memorize when this is true and when this is not. All right. So that's our answer. And we can just kind of truck along through these. Who says truck along? I think I know who's to blame for that, but I'm not convinced. I don't know for sure. So over here, you might think, all right, we got this, Jason. We got this. Let's just cancel them out. We'll cancel them out. We get 2 pi over 3. Don't do that. You try to cancel these out, and your calculator will back me up on this. You'll be wrong. You don't want to be wrong. All right. So again, sine of 2 pi over 3. Remember how we do that? 2 pi over 3 is this over here with a reference angle of pi over 3. And we fill in the triangle using special triangles. Square root of 3 is right here. 1's right here. 2's right here. Because we're going to the left, the x-coordinate's negative. Going up, the y-coordinate's positive. All right, so the sine of 2 pi over 3 is going to be root 3 over 2. But now, what's the inverse sine of root 3 over 2? We need to go back to our triangles. Sine of what angle is root 3 over 2? It's this angle, root 3 over 2. That's pi over 3. So now what we started with is not what we ended with. And the reason why is, again, go over to this table. What is the range of sine inverse? It's negative pi over 2 to pi over 2. So because this was not in our range, they didn't just undo each other. We need to get a similar angle with the same reference angle and the same sign, sign, S-I-G-N, positive or negative, which will be in the first quadrant. All right, and so these examples are the really good ones that are gonna get you thinking. Also, if anyone's moving on to take calculus after this trig class, this sort of stuff is gonna be really, really useful for what are called trig substitutions. And they're really neat integrals, actually. They're really cool. I want to start talking about trig integrals right now, trig subs, but we can't do that because this is a trigonometry class, not a Calc 2 class. So I'll hold myself back for your guys' sake. Let's keep on going. Cosine inverse of cosine of 2 pi over 3. Let's use a shortcut for this one. I told you guys I wasn't going to talk about the shortcut. Can we use the shortcut on this one? In order to know whether we can use the shortcut, we need to look over here. Is 2 pi over 3 in this range? Because 2 pi over 3 is in this range, remember 2 pi over 3 is 120 degrees. This is 0 to 180. So 120 is in that interval. Because 2 pi over 3 is in that interval, we could use a shortcut and say, okay, these essentially undo each other. We get 2 pi over 3. Alternatively, you could say that cosine of 2 pi over 3 is going to be negative 1/2, and the inverse cosine of negative 1/2 is 2 pi over 3. You could go through the logic that way. So see how we're combining all of these different concepts? So many different concepts are being combined right here. And this is how the whole class is going to go. Everything we talk about, with the exception of 8.2, we're kind of never going to use 8.2 again. Sorry to tell you that. With the exception of 8.2, really everything we learn, we're just going to be learning and using again in the future, which is why it's so important to always make sure that you're keeping up with the material. Because if you don't understand chapter 7, chapter 8 is going to be way harder. If you don't understand chapter 8, chapter 9 is going to be way harder, etc. All right? So always make sure you're keeping up. And as always, if you have any questions, reach out to me, okay? So let's, again, just keep going. We just did part... I'm lost. We just did part C. So let's go on to D. That's next. All right. Inverse cosine of the cosine of negative pi over 3. So again, let's say we want to use our shortcut. Negative pi over 3. That's not in this range. Shortcut, no applying. That's terrible English. Shortcut doesn't apply here, so let's just do a step-by-step. All right, the inverse cosine, well, what is the cosine of negative pi over 3? We draw a picture. Negative pi over 3 is down here. Reference angle is pi over 3. Consult our special triangles to say pi over 3 looks like this. And the x-coordinate's positive, so this stays positive. The y-coordinate's negative, so that turns negative. Cosine is the adjacent over the hypotenuse. It's 1/2. So we replace cosine of negative pi over 3 with 1/2 since they're equal. All right. And we just do it step by step. Work on the inside. I use this metaphor in my other class last semester. They didn't like it. But in math, right, you work from the inside and then you work your way outside. It's kind of like in that Alien movie, right? Where the alien grows inside of you and it starts on the inside, but then it like bursts through your stomach and then it's working on the outside. It's the same idea with math. Okay? So and then anyway, we go, what is the inverse cosine of 1/2? Well, what angle is going to give us a cosine of 1/2? Cosine's adjacent over a hypotenuse. It's going to be this angle, pi over 3. And because the ratio is positive, if the ratio is positive, the inverse trig function value will also be positive always, and in the first quadrant. Positive ratios are really much easier to find inverse trig functions. All right, let's keep going. Do a tangent one. It's been a while. Tangent inverse of tangent of pi over 8. Let's see if we can use the shortcut. Is pi over 8 in our domain? Sorry, in our range. Pi over 8 for tangent. Yep, that's right there. Pi over 8 is 22.5 degrees. So let's save ourselves a little bit of work. And there we go. All right. If it were like 7 pi over 8, then we'd have something different. 7 pi over 8, then our answer would turn to negative. You know what? Let's do it. Tangent inverse of tangent of of 7 pi over 8. Now this one's a really interesting one, and I didn't include it in my notes for a reason, because we can't use a shortcut because 7 pi over 8 is not in the range of inverse tangent. Okay. But unfortunately, 7 pi over 8 is also not one of our special triangles. So anyway, what we're going to do is we're going to look over here. 7 pi over 8, it's somewhere over here. Reference angle is pi over 8. So essentially, all we need to do is take this angle to an angle with the same reference angle in the right quadrant. So this is going to be, tangent's going to be negative over here. But for inverse tangent, we need to be in the first or fourth quadrant. So we just look to a similar angle over here, which is negative pi over 8. And that's kind of another way to apply this shortcut when you have the same thing right here. All right, but this is, I don't think you're going to see something like f. This is just me getting a little excited and showing how E and F would relate or not relate, whether it's in the range or not in the range, whether the shortcut applies or does not apply. Okay, so let's go on. Sine inverse of the cosine of 13 pi over 6. And you might say, whoa, slow down. Slow down. These are not the same functions. These are not inverse functions. They're certainly not inverse functions. Inverse sine and cosine are different functions. So what do we do? And the short answer is, don't worry. We do it the same exact way we've done before. We just can't use a shortcut anymore. So no shortcut means more practice, which is always good. All right, so we go over here. 13 pi over 6. This is a garbage. I don't want to deal with this angle. If we convert it to degrees, we get 390 degrees. Or we could keep it as radians. All right. I want to know a coterminal angle with this, because 13 pi over 6 is way too big. Whenever you're looking at graphing or seeing how big these radian angles are, just look at the coefficients. 13 over 6. That's bigger than 2. That's 2 1/6. Okay? So it's more than 2 pi. So it's like we're going all the way around and then a little bit more. And specifically, if we look at 13 pi over 6 minus 2 pi, we can find a coterminal angle, which is much easier to work with. It's just pi over 6. So we have our pi over 6 triangle right here. First quadrant. First quadrant makes us pretty happy. Well, what is the cosine of this? It's root 3 over 2, adjacent over hypotenuse. So since they're equal, we just replace them. Am I running out of ink? I hope not. All right. And now we say, okay, what angle do we need so that the sine of that angle is root 3 over 2? What angle gives us the sine of root 3 over 2? Well, not pi over 6. Sine of pi over 6 is 1/2. But the sine of pi over 3 is root 3 over 2. Okay? So our answer is going to be that pi over 3. And that's how you approach these ones. And it really, really, really depends. And it is very important that you have a good understanding of example 2. Because if you can't easily do example 2, well, this is just example 2 with more steps. All right, so watch out for that. Let's get into some more exciting ones. Let's do one more like this, and then we'll move on to the next level. Inverse cosine of the sine of negative pi over 4. All right, so sine of negative pi over 4. Let's draw a picture. Negative pi over 4 is right here. This is going to be 1. This is going to be negative 1 because the y-coordinate is negative root 2. So sine of negative pi over 4 is the opposite over the hypotenuse, which is negative 1 over root 2. And you can rationalize the denominator if you need to, or if you want to, but you don't need to for me. All right. And now, okay, what angle gives us 1 over root 2 when we take the cosine of, and remember, you might want to go off to the side and say, well, the reference angle is going to be pi over 4. It's the only way we get cosine of something being 1 over root 2. But then what quadrant do we need this to be in? Remember, cosine is the weird one. Cosine, the range of inverse cosine, is in the first and the second quadrant. So to be negative, because we have a negative ratio, we need to be in the second quadrant here. So we need to find something with a reference angle of pi over 4 that's in the second quadrant. You draw a picture. You're going to get 3 pi over 4, or 135 degrees is your answer. All right. That's essentially it, until we go on to the final chunk of examples. So let's final chunk it out. We are in letter, I really need to remember these. Letter I. All right. What is the sine of the inverse cosine of 4/5? Now, these ones are really fun for me because we're not actually finding the angle. So notice how this is different. In all the previous ones, the inverse was on the outside and the function itself was on the inside. Now we're flipped. Okay, so to do this inside, it'd be cosine of what angle is going to give us 4/5. But if you type that into your calculator, you're going to get an approximation. And approximations have their place, but we can actually find the exact answer here if we just use our brains. So let's look at this inside part, right? Essentially, this is cosine of what angle gives us 4/5. We don't really need to know the angle. We can just draw it. Cosine of what angle is 4/5. Wait a minute. This is very similar to example 3. And let's just say, who needs to find theta? Let's say, forget about theta. I don't care about theta. Watch this. We need to find an angle such that makes this true. Let's just say we found it. This inverse cosine is just going to be some angle. And who knows what angle that is? But if we go back to chapter 7 and just forget we're here, which you might want, at this point in the lecture, you might want to forget you are here. All right? If I ask you what is the sine of theta for this triangle, you know how to do this, right? Sine of theta, it's going to be the opposite over the hypotenuse. Oh, well, we don't know what the opposite angle is here, but we do know Pythagorean Theorem, right? A squared plus b squared equals c squared. So 4 squared plus, I don't know, whatever that is going to equal 5 squared. 16 plus b squared equals 25. Subtract 16 from both sides. You get b squared equals 9. Take the square root. B is 3. Aha. So this is 3. Sine of the angle is the opposite over the hypotenuse, which is just 3/5. We didn't even need to find theta here. Theta is a middleman, and we don't need to pay the middleman. You could have approximated theta, and then you would have an approximate answer, but now we know the exact answer. The ratio is 3/5, 0.6. And that's how you can approach these ones. Skip the middleman. Just draw a picture. We'll do a couple more, though, for extra practice. Find the cosine of the inverse tangent, of 5/12. And again, when the inverse is on the outside, we solve it one way. When the inverse is on the inside, we solve it this way, with the theta middleman. So, remember, right here, this inside, this is some angle. Because that's the whole, one of the themes so far of this first half of the semester, is that sine of an angle gives a ratio, and inverse sine of a ratio gives an angle. It goes backwards. So this value on the inside is the inverse tangent of a ratio, which means this is some angle. And I don't know what the angle is, and to be honest, it doesn't matter. Let's call it theta. So we know, right? Let's write this one out, be a little bit more clear, right? Since inverse tangent of 5/12 equals theta, we can go back to example 1 from this section and look at this from the reflected version. That tells us that tangent of that angle is 5/12. And as soon as we know that tangent of an angle is 5/12, we can draw a picture. Tangent's opposite over adjacent. Opposite's 5, adjacent's 12 is one such triangle. Well, then what we need to do is we are curious about what is the cosine of whatever that angle is. You don't need to find theta. Skip the middleman. That's going to be 12 divided by the hypotenuse. If you're really good with special triangles, you can figure out that the hypotenuse is 13, or use a Pythagorean theorem. 12 squared plus 5 squared equals c squared. 144 plus 25 equals c squared. 169 equals c squared. Square root, you get c is 13. All right, so the cosine of theta, we don't even need to know what theta is. It's 12 over 13. All right, and that's all there is to it. Until we get to the really, really good ones. So if you're not taking Calculus 2, this last example is probably not that important. But if you are taking Calculus 2, I want you to put on your glasses. I want you to turn off the music. I want you to just focus on this last example for today, because this is the heart of trig substitutions. Cosine of inverse sine of x over 3. We have variables now. Okay. But the good news is, and why I'm only doing one of these instead of doing more, is we solve it the exact same way. It's just now there's variables. So again, this is going to be some theta. The inverse sine of a ratio is an angle. So if we draw our triangle, again, your triangle doesn't have to be accurate. I don't even know what this triangle is going to look like. But if this is some angle, right? If inverse sine of x over 3 equals some angle, what that tells us is that the sine of that angle is x over 3. Opposite over hypotenuse. So this will be x, and this will be 3. If we don't know what x is, and it doesn't matter, well, it mostly doesn't matter. There are some restrictions, but we won't be worrying about that in this class. So to find cosine, cosine's just, right? We really just finding cosine of that angle is just the adjacent divided by the hypotenuse. Well, we don't know the adjacent. What are we going to do? What we've been doing for the last two problems. We're just going to use Pythagorean Theorem. All right. So let's call this A. A squared plus x squared equals 3 squared. And you might feel a little nervous. We got multiple letters here, but it's okay. We're just solving for a squared. So we need to subtract that x squared over. We're going to get a squared equals 3 squared is 9. 9 minus x squared. Take the square root. Be very careful here. A is the square root of 9 minus x squared. That's as far as you can go. This does not simplify any further because of the subtraction. If it were the square root of 9 times x squared, then yeah, that'd be 3x. But this is not 3 minus x. Subtraction and addition make a bunch of problems for us. This is as far as you can go. So if this side is x, this is going to be the square root of 9 minus x squared. And it looks a little ugly, but it's not that bad. So cosine's the adjacent, which is the square root of 9 minus x squared, divided by the hypotenuse, which is 3. And these sorts of things are very good practice. And I put a couple on the homework. Very good practice if you're going to end up taking calculus. And if you're not, they're good practice, because if you can do this, the other ones are going to be easy. And that's basically the section. And that's the end of the chapter. Next week, we're starting chapter 9, which will be a fun time. I'm really excited for chapter 9. I hope you guys don't hate it. You might hate it, but I'll at least love it. And hopefully I can impart some of my joy to you. That's it for this week's material. Let me know if you have any questions, and have a good morning, night, midnight, afternoon, whatever time it is for you.